In our last class, we ended with the definition of electron affinity. So we came to know that electron affinity is the amount of energy released when an electron is added to the outermost neutral gaseous atom to convert into a negative ion. Okay. Now today we'll see its trend. Okay. Today we'll see its trend. That means how it will differ in a period and across in a period and down a group. So in a period, while moving from left to right of the periodic table, as we know, the atomic size decreases. The atomic size decreases and the nuclear charge also increases. Because of that, the electron affinity also increases. Okay, therefore, the electron affinity is highest for group 17 elements. The electron affinity for group 17 halogen elements, it's very high. Okay, whereas it will be least for group 1, that is alkali metals, because as we move from left to right, group 1 elements, that is lithium, and if you see these halogens, okay, halogens, they will have the highest electron affinity and they will have the least electron affinity because it increases. Okay, now when we move down a group, so when you move down a group from top to bottom, the atomic size, as we know, it increases. Okay, therefore it causes a decrease in the electron affinity value. Therefore it causes a decrease in the electron affinity value. Okay, now next periodic properties we need to discuss is electronegativity. Okay, electronegativity. So the definition tells us the tendency of an atom in a molecule to attract the said pair of electrons towards itself is called its electronegativity. So the tendency of an atom in a molecule to attract the pair of electron towards itself is called as electron affinity. Okay, it's called as electron affinity. Now regarding its trend, that means how it will differ in a group and across a period, as we know across a period there is a increase in nuclear charge due to increase in atomic number. Therefore the electronegativity value increases. The electronegativity value increases. Whereas when you move down a group, as we know, there is an increase in atomic number and the nuclear charge also increases and the atomic size also increases. Therefore the nuclear charge hence that is formed will lead to electronegativity decreases down a group. That means it will lead to decrease down a group. Next thing that we need to discuss is a very important diagonal relationship. What does it mean? Sometimes you may ask, define diagonal relationship. Okay, so the elements of the second period show resemblance or similar in properties with the elements of the next group of the third period. Due to very less electronegativity difference, this leads to a diagonal relationship. For example, let us try to understand. We have taken two periods element, period 2 and period 3, lithium, beryllium, boron, carbon, and sodium, magnesium, aluminum, silicon. Now in this element, lithium will have a similar properties like magnesium, beryllium will have a similar properties like aluminum, and boron will have a similar properties with silicon. So if you see, then they are showing a diagonal relationship. So this relationship we call diagonal relationships, and the elements which are matched in this way are they are called bridge elements. They are called bridge elements.